You're
Can you
able
see my
to.
screen? This is Nani speaking, and I just welcome you on behalf of VenEma on this session on big data. We are a bunch of people very passionate about this field, and I just hope through this session I'm also able to bring you some clarity on this particular topic. I'm sure being from IT, you must have heard about it. So in this particular session, my motive is to start from the very beginning on what big data is, how it came into being, give you some unconventional examples. I'll be taking some very unconventional ones on companies working on big data and how they have leveraged this particular technology. We'll talk about definitely Hadoop, MapReduce, the Hadoop ecosystem, and then NoSQL databases. And definitely after that, I'll be discussing some job opportunities. So let's begin. What actually big data is, or why is there so much hype around it? So evolution. This I've divided the entire history of big data in three major steps according to what I have understood it. So let's just go back a little while in the history and in the past and just think about it when computers were introduced in our lives. So data at that time was a very small thing. There were a bunch of people working on big data on these machines all over the organization. They were uploading data, they were downloading data. It was okay. It was just working. It was good. The manual labor was reduced. It was going fine. Everybody was happy with it. But then came internet, and it was we can remember it was a dot-com boom time. Lots of companies shipped in. They want to leverage the technology of internet. But what internet actually gave was a single individual the power to generate data. It was this single power that made it so much huge. So even a single individual with the help of a device all over the world could generate data, could upload data and download data from internet. And it was this first step which actually you can say marked the beginning of big data. It was this particular first step. And that we can also remember at this time Google was there, and a lot of company Amazon just came into the market, and we actually know these are the key players right now also in the current scenario in this particular field, big data. And the third step, the present world. So right now if somebody want to describe it, it's like it's not just the individuals, it's machines, sensors, devices generating data. So we are surrounded by so many machines all the time, computers, tablets, smartphones, smartwatches. And right now if you see, there are so many devices, even extensions being developed that can attach to your body or your smartphone and can take a lot of information and generate a lot of information. So it can actually think about it. It's something like Matrix. It's kind of a digital world we are going to live in, and it's just increasing every second day. So why is so that's why it's big data, because adjective big actually means that the data became so much huge that the present technology stack could not handle it. It just became completely obsolete and a new paradigm was needed. So that's why the complete adjective big is being attached to data right now. So from this slide also you can see it's like a matrix kind of world. You can get a lot of value from the data because your data is being generated by machines who are actually sensing the world around you, and definitely that means that data is the new oil. It has become so much important right now. That every single bit of data can give a lot of information which can be used commercially also and in different other fields also. And in my particular presentation, I'll be focusing on the under unconventional use to give you a broader picture of why it's become so much important in every single dimension of human life right now. Moving forward, I'm taking some example of companies who have pioneered the world in big data analytics, and these are some unconventional ones, as I already said to you. So the first example is IASD. IASD is a startup by DARPA, D-A-R-P-A. I don't know the exact pronunciation. I'm just saying DARPA. I'm pretty sure that most of you around in here must have heard about it. I'm just giving a brief introduction on DARPA. DARPA is the technological hub of US Defense System. It is the place where top technologists from all over the world, that means physicists, computer scientists, neurologists, neuroscientists, every single person from the pioneer who have pioneered their work in their particular field collaborate and develop technologies for the US defense system. And if you go deeper into it and you Google search it, you will actually see that most of the current technologies also have actually found their sources and their roots in this particular DARPA organization. People who have developed these particular technologies actually must have worked somewhere at some point of time in DARPA. So as this is a startup funded by DARPA, and if I'm saying it's funded by DARPA, it must be really important. So for example, I've given these three pictures on how how ISD is actually working on big data analytics, and it's very pretty unconventional one, as I already told to you. This is in the first picture in the A event. This is actually a 3D model of clashes that happen in Baghdad. So if you see that there's kind of a simple small pattern emerging. We have all watched Batman, right? So there's a very famous quote on that order. There's an order in the chaos. So that is what this is highlighting actually. That between these riots and this violence happening, there's some kind of pattern. There's something being targeted. Moving forward by the B and C, they are actually able to discover this pattern. It's in the second stage, and they can definitely see that in this particular killing and rioting that's going to happen, there's something very organized going on. Behind all this chaos, there are people being targeted. There's specific people that are being searched and saved, and there's specific people being killed in the process. And all this is kind of a cover up that's happening. The B and C are going to this particular red and yellow patterns. They are actually a proof of that. By the time it's D and E events and the killings and everything, the particular event moves forward. This particular pattern becomes more prominent and a definite proof of that proof that some terrorists, some Al Qaeda terrorists, were being saved and freed from the breaks, from prison breaks, and some people were being targeted, killed, and some people were freed. And mind you, if we take these three steps, anybody can think that okay, from this 3D model alone, they were able to discover it. There was nothing else they used. It was data that was fed into a system, their algorithms, they were working on it, and 3D model was made, and they were able to come into this conclusion. I believe if somebody may ask me, this is pretty huge to actually get this kind of information from a 3D model. Second example is of this is not exactly what you say big data example, but this is something which can actually give you a picture of how much important or how powerful data analytics can be. So this is a picture of 1854 London cholera epidemic. What was happening was that there was an outbreak of cholera in London, especially around this region, Broad Street, and people were dying in massive numbers. I mean that was why it was epidemic, and nobody was able to understand how to curb this particular situation. So Dr. John Snow, what he did was he actually mapped the deaths of people to the places they were living in, and he would just color the entire thing out on the map. So if you can see here for yourself also around Broad Street, this particular black area is very prominent. Anybody can actually notice it, and he could see that they were already wherever the deaths were happening in massive numbers. They were around this water pumps, and you can see that because this is so much blacker, and then this must be the center of the epidemic and things are moving outwards. He was he was able to pinpoint that there was something really wrong in the water system of the area, and he was right. He was able to stop this epidemic using this particular map, and he just went to the water pump system and and it was fixed, and the situation was actually curbed at the right time. Otherwise this could have become a major problem going down in the history. So I believe this is pretty much clear, and this is I believe a very good example back in the history of data analytics, or you can say big data analytics, that how much power proper data modeling can actually give to a single individual. In the present time also you can see this on Google flu trends, where they become very much famous, and if you go and research on it, you can understand that it is yet a very good example of big data analytics, and in a very unconventional sense, not on the commercial sense even. So moving on to Hadoop, any questions, speaker? Anything you want to ask? Yes or no, maybe please? Or shall we move forward?
Move forward.
Okay. So taking the second stage in our demo, we come here to Hadoop, the elephant. All right. So Hadoop, as we all know, is the technology, or let's say the first thing that comes to mind when big data analytics or big data is concerned in the current scenario. So when we talk of Hadoop and big data, Hadoop is definitely a framework. It's not just a single technology. It's actually a framework of technology which deal with every single dimension of big data analysis. That means from capturing the data to modeling it to refining it or putting algorithms on it, distributed it across different stages. Everything can be done through a technology that is part of the Hadoop framework. And we are taking the one which was just came in the market and are still there and are very important. And but we all know that there are a plethora of technologies that are being developed right now in Hadoop. So let's move forward and let's see what I'm trying to say there. So essential steps to utilize data. Uh, when we talk of Hadoop, we are actually talking about big data and everything. We definitely know that it's not going to fit on a single machine. So that means we are going to have to let's say increase our resources. That means when you talk of resources, there's just two things on a machine: storage and processing. And talking about big data, we need more of this because how we're going to analyze it anyway. So that means that they just we have to scale up, right? So scaling up, that means there are just two paradigms. The vertically, that means add more resources to a system. So that actually this is not very something new. This happened in the history also, that people would get big servers, high-end machines with more capacity and just used it for data analysis when the data was really huge. The problem with this paradigm in big data is we are talking about data that's been generated at huge speeds, huge quantity, unstructured, semi-structured. There's no definite structure to it, and we are not sure of the consistency. Basically, the four V's with big data: volume, velocity, veracity. So scaling vertically is not an option for us, and it can, because if we are going to have custom made machine, it might solve the problem for a single time, but it will not work properly because it definitely it's going to add a lot more cost to your particular business. And when we're talking about business, you have to keep your resources or your input as minimum. Your investment should be minimum, and this is precisely the problem basically faced by Google when it came into being. And we know that Google is actually very much famous for the way it utilized the or solve this problem. So what they did was scaling horizontally. That means adding more nodes to a system. And these nodes are simple commodity servers, simple machines that do not cost much. You can add them on the go as per the demand increases. And this was actually popularized by Google, the way they solved their problems, and then it actually went down to other companies as well. So we are the first thing that's very important according to me, and that should notice is that Hadoop actually works on scaling horizontally. That means we are adding more nodes to the system, but these nodes, they are the simple commodity servers. That means the input to your business when you're trying to scale for big data is actually very reduced. It actually if you think properly, it is a simple open source software running on very cheap commodity servers, and that drastically slows down or minimizes your input to the business. Okay, I hope it's clear. So when it's decided first thing that okay, you're scaling horizontally, that means you are working with cluster of machines. The first thing that should come to your mind when you're talking about cluster of machine is it's a distributed system, and if it's a distributed system, that means there's network involved. And I want to stress upon one thing, that when you talk about a network of machines, network is a very costly resource. I mean, it is the first single factor that can actually make or break your entire system, your entire business. Because when utilized properly, it can solve the entire problem of big data when utilized properly. But if there is a problem that's definitely going to come in this particular resource, it can bring the entire system down. So it's a very, very costly resource. And I would just want you to just keep this in mind, because down the slides I'll be asking questions on one or two questions on this particular topic, and this is the, you say, hint to it. So Hadoop, as I already told you in the beginning itself, that there are two major resources that are going to be ultimately, you can say, optimized or utilized in a very intelligent way in any distributed system. Even if you are talking about a bunch of machines working as one, working as a cluster, and then ultimately storage and processing. So at the level of Hadoop, when you're talking about a cluster of machines which are working as one, you have Hadoop HDFS, which actually maps to your storage. It takes care of the storage of a distributed system, your cluster. And then there is Hadoop MapReduce, which takes care of the processing of the entire thing. So, so again, it's the same thing. Even at the level of a single machine, the storage and processing, which is being definitely used for any kind of problem, even in the distributed system, it's again the same thing, the storage and the processing, HDFS and MapReduce. But again, I told you just in the previous slide, the major important factor is of network, how you're going to use your network properly, so that there is the optimized use of this particular resource. So first, let's tackle Hadoop HDFS, and I'm taking very broad level summary of the entire thing, and please be free to ask any question, because I'm going to give a lot of information on this particular topic in this single slide. So Hadoop HDFS. Hello, any questions?
Go ahead.
Yes, because somebody was saying something.
No, please go ahead.
No problem.
No problem.
Yeah, sure. Okay. So Hadoop HDFS, I already told you that Hadoop is a framework. It's a framework written in the language of Java, and it's a master slave architecture. That essentially means, let's say you have 5 machines, or let's say you have 5 desktops or laptops in your entire home, and there is no internet connection. And I say to you that, okay, you have to store data. The data you have, you want to store it. So, or even in my slide also, I mentioned that you can use a bunch of machines. So you have a bunch of machines, they're connected to each other, let's say by LAN or something. You can use this bunch of machines using Hadoop as one machine. Okay, what you will essentially do is, you have one machine which is a very good server. Let's say it has good memory capacity. You will go and start a process called name node on it. So ultimately, it's just a Java process. It's running on a node or on a machine that you have, and this makes it the master process at the storage or the HDFS level. Now, what name node does it stores the entire metadata of the entire system, entire file system. Yes. So your file system is distributed because it's in a number of machines, and this entire metadata, the file, the particular, let's say the part, the chunk that is going to store it, the chunks which are called blocks on HDFS, and how many they're going to be replicated, what is the machine that is going to store this particular chunk of data. This is being stored by the name node. Then you have your workers, the actual people, let's say even in organization, the actual people who work. So here at this particular level, HDFS, you have nodes of machines called data nodes. Again, these are basically processes. What you will do is, you will go and actually run these processes, Java processes, on these nodes of machine, and these machines will be actually responsible for keeping your data. So I'm taking very high level view of it. Any questions, please ask, and you can interrupt me. So even in this particular figure, you can see that there is a name node. This is a machine which has a lot of memory. It's storing the entire metadata. There are data nodes. Each single block is a machine, and it's storing a chunk of data called blocks. And blocks, I would just make it clear, are physical division of data. That means you can actually visualize it that given a block of data, given a file of data, is getting cut into physical blocks or physical chunks called blocks, and these are thrown over the system, and it's being decided by name node, or at this is pretty automatic. The system is intelligent enough. So we can see that, okay, for block 1, it's on first machine and third machine. Block 2 is on second and first machine, and it is a replication factor of 3 is being maintained. So the next question that should come into your mind is why replication and fault tolerance. When you're talking about big data that and you're using commodity servers, it is very natural that over a cluster of machines, your particular node can fail. Any particular node can fail, but you cannot have that because you have to keep your system up and running all the time. So what do? Either you just pray to God that this never happens, or definitely you define a paradigm for it. So using replication and fault tolerance, you actually make sure that your system is up, running, and available all the time. Replication, so that when you're talking about big data, there can be many number of concurrent users who want to read data or access the data. So replication takes care of that. And of course, fault tolerance also, because if you're maintaining a replication factor and you're basically making copies of a data, so let's say the replication factor, which is default in 3, a 3 replication factor makes it sure on a very standard level that if your single machine is down and you want that it should be up on some other machine, this can be taken care by the system entirely. So there are three main topics which I'm stressing in this particular slide on HDFS level. First is the physical division of data by blocks. Second is providing replication, and third is fault tolerance. So I believe this is a pretty much broad overview of entire HDFS landscape. Any questions on this particular topic? There was a lot of information. Any questions, sir? Any
Pe-
doubt?
People, you can,
They're bound to be doubts.
Kishore, you can, if you have any questions, you can go ahead.
No. All right. So because I'm asking that because HDFS is pretty much covered in this slide, we'll moving to MapReduce. So
Please.
Hadoop MapReduce. I'll be explaining this topic using an example. So let's say that you are a very intelligent person. I hope all of you are, and you are given the responsibility of declaring whether a single party in a country, let's say XYZ, and there are two parties A and B, which party is the winner for a particular election. That's a huge responsibility, and definitely this is a big data problem, considering how many people are there in the country and how much data you will have to face. So let's take the first very naive approach that there are voting booths on the different demographical area of the country, and you're getting, and what you do is you define a digital system. So the black arrows, these actually for the network, and taking a very brute force approach, you'll get what you say, okay, bring all the votes to me and I'm going to give the final count. Very nice. So okay, all the votes from every single area are being sent to you, let's say over a digital system. So these black arrows are for the network, and you get the entire data to you, and you just start counting, and we don't know, even using a very good computer and everything, how much time it's going to take. So the first problem of, definitely anybody can see that this is a very not a very optimized approach. The second problem which generally people overlook is of network. Again, I'm stressing on that having this kind of data over the network of machines you have, can bring your entire system down, as I already told you. And I already pointed to you that network is a very costly and precious resource. So if this kind of data is moving over your network, it can, and you're talking about big data, this is not going to work for this particular problem. And if anybody has a little bit information on Hadoop, the way it works is this, that what had Hadoop has done for big data, and that this is also a general, you can say, rule solving big data problems. We take the reverse approach. In the real world, what happens is, what used to happen was that we took the data to the processing. But over Hadoop and in general big data scenarios, we take the processing to the data, because here we talk about a huge amounts of data which which should be minimized over the network, the transfer of data, and plus we try to make it minimized over the network, and we try to move the processing, because we are talking about a cluster of machines working as one, and this is going to be a very huge cluster. We have very huge network of machines that works here. So when talk about Hadoop MapReduce, the processing, this is a key factor for this paradigm, because MapReduce is actually an algorithm to work on a single We work on a cluster of machines to solve the processing problem of big data. So moving forward, I'd already specified the single problem faced by what is the single most important thing you should keep in mind over a cluster of machines. So let's move to the third stage of the problem. What you do is you take it a bit smartly and you define two roles for the people in your team called mappers and reducers. So what these people do is they go to the particular voting booths and they count the number of votes for that particular area or what that particular voting booth and send to a single place. So as you can see on all these voting booths, I have just used M. So these are the people you're just counting, and locally you can say locally counting the entire count of votes and sending to you, where you have defined a person with the role R who is very good in mathematics and he's counting the entire global count. So if you see this way, now over the network you have significantly reduced the transfer of data. Now just a count, a local count of the for the two parties is coming over the network. So this actually uses your network in a very optimized way. And at the central position, let's say there are two or three people called R, they will do the entire total global count. So is it clear? Any doubt on this? Is it the process clear? Map reduce process.
I'm good.
Good. Okay. So I believe it's clear. Let's move on the next slide. So this is the general paradigm of MapReduce over a cluster of machines, and this is a bit technical. Not you should. Okay. So the blue part here, the split and the shuffle that you're seeing is, and these small blue arrows. This is the part which is automatically taken care by the framework. That is your Hadoop framework. So splits, you must be asking what splits are. Let's say normally there's something called logical partitioning and physical partitioning, logical addressing and physical addressing. So over your HDFS, your blocks are the physical division of data. That means essentially what it's like, you have taken a file and you cut it using a knife into 3 or 4 whatever parts you can get, and these are pretty huge, as I told you, because of the big data we are solving. Hello, was anybody asking something?
Two folks joined, so you can go ahead.
Okay, again. So, but when you're talking about splits, that essentially mean is that the entire data that you're going to read it, let's say you have to read a line, okay? So what might happen is that this particular line might be divided into two blocks. The major portion will be in block 1 and a smaller portion will be in block 2. But this has to be done by this particular block of this particular line has to be read by a single mapper, okay? So what it happens is that the split defines that, okay, you read the data from entire data from block 1 and some the little data that's in the block 2 can be move over the network to this mapper. So that is what split is, the logical division of data. It defines a range of data that has to be read over the HDFS, and it might cross the boundaries for a physical block. So this is what split is, logical division of data. Mappers, you don't have to think about combiner, we'll discuss it later. It's not very important. So mappers and reducers, this is what you define as a developer, as the one who is writing the MapReduce code. What happens is that, again I told you that Hadoop is a Hadoop is a Java written in Java. So what is essentially is that you will override the given code, override the classes that is given in the framework, and you give your own logic. So like let's in the previous example, we gave the logic of counting the votes. So what you'll do is you'll override the mapper class here, and you will give your logic that, okay, you have as a mapper, as a map task over the network of data where this data is stored, you will count the total number of votes for that particular area for the party A and B. It will move to combiner. Combiner is a local aggregation of the data. That means for a particular mapper, whatever comes to your mind will be locally reduced here, so that it's an LTP local reducer. That's enough for right now in this slide. Then what happens is that over shuffle and sort phase, this is called shuffle and sort phase, and this is again automatic. I told you that the blue parts is being taken care by the Hadoop framework. This particular data is we decided where this particular data will go to which reducer. And reducers, as I already told you in the previous example, also these will issue the global count. Or this is what happens is that in the entire data over the entire framework, entire cluster comes to two or three reduced tasks, which is responsible for the local reduction of the entire data. So in the previous example, as also this is where you will define your entire count of the entire data that's going to come to you, the entire count that's going to come to you from the mappers. That is when this is going to take place. Any question? Is it clear? There must be some kind of question. Any questions, guys?
Let mapper.
Should I go forward? Yeah, because in the next two slides, I'll be asking a question from you.
Unmuted.
So should I move forward? Yes or no?
Looks like you can move forward, Anusha.
Okay, sure. So we have just finished the explanation of two many important components of Hadoop, the HDFS and MapReduce, as I told you, the storage and the processing. But of course, this is not the entire thing. We have just discussed very basic components of the entire ecosystem. Now, if you see this in this slide, this is the entire, or let's say the major parts of the Hadoop ecosystem. There are a lot many other components also that have been added as we move forward. But this is the, you can say the original stack of the Hadoop ecosystem. So what it deals with the major components of dealing with big data. So using, if you can see that there is something called Flume and Scoop. These deal with that. These actually deal with getting your data into the HDFS, or let's say in the Hadoop system. That the entire data, whatever is there, like the web file, structured, unstructured, everything, you can take using these Flume and Scoop. You can push your data into the Hadoop framework. After that, you have definitely have your processing part called the MapReduce framework. You have your database, your NoSQL database, HBase. You have your data warehouse system, Hive, data analytics system, Pig. You have your machine learning part taken care by Mahout, and you have a workflow scheduler called Apache Uzi. So if you see carefully, every single dimension of handling big data, of analyzing it, of storing it, of modeling it, is being taken care by in every single technology that is there in this particular slide. So I hope it's clear. In the next example, everybody must have heard about word count example, the famous hello world example of MapReduce. I just gave you an example on the word count. A third very unconventional example is of the Lord of the Rings movie. And I'm taking this example to make it a bit clear that when you are solving a big data problem, or you're deciding to solve a problem on a cluster of machines, there's some paradigm or some parameters that you should be clear of so that you can decide how you're going to solve that particular problem. Because it's not going to be very simple as the word for example is. So Lord of the Rings movie, what happened is that there's several thousand individual characters simulated. That means over a cluster of machines, there are a bunch of different machines deciding who throws what at whom. So elaborating a bit, let's imagine a battlefield scene. So in the left corner of the scene, there's some people throwing something. They might be fighting some kind of with some kind of weapons, and some people might be, you can say, dominating the other party. But when you talk about a battle scene, at the other corner of the fight, it might be something very opposite. It might happen that nobody is winning. It might happen that some party is actually is able to dominate one party, or they're using some different kind of weapons. So if you are given a task that okay, this particular battle scene has to be simulated on a cluster of machines, you can very easily see that there can be a bunch of machines which can be given the task of simulating one part of the battle scene, and at the same time there can be a bunch of machines which can decide to take the battle scene, or take that part of the battle scene in a very different way. And if you combine all these parts, you will get the entire picture of the battle scene. So if this is clear, and I'm taking hypothetically that it's clear to you, can you all tell me that what is common in all the examples that I have given of MapReduce right now? That if you are given a problem on big data for a cluster of machines, what is the single important thing you will look for? to decide that it can be solved on a cluster of machines? Can anybody answer me, please?
Unmuted.
Splitter.
Yeah.
Kishore, please, you can go and answer.
Yeah. We need to do the splitter and shuffle sort, right? You can reduce the data. That is the purpose.
Okay. Well, I'm asking about a single important thing that you can say, okay, this is the thing that makes it that I can solve this on a cluster of machines. The single thing I will look for. Okay, let's move forward then. The single common thing, if you see very carefully in all these examples, is that you are given a problem which can be broken down into simple small units, which can be solved individually. So I gave the Battle of Sea example, battle example for this only. That when you are talking about a cluster of machines, these machines are working as one or a network, and you have to solve a computing problem on it. The first thing that you should look for is that one particular big problem can be broken down into smaller problems, and these smaller problems can be solved individually, and they are independent units. And after solving these problems, you can get the entire picture of the problem, you can get the entire solution. So it's basically divide and conquer, which we all know of ultimately. So I hope it's clear. Moving into next slide. NoSQL. Any questions? Because we are done with the Hadoop part of the slides, Hadoop part of the session. Any question you want to ask? Something that is not clear?
Yes.
Yes, please go on.
Yeah. Hadoop is like a database. You're saying like a framework, right?
It's a framework. Hadoop is a framework.
Framework. Like it means like a SAP company, right? Is it Hadoop is?
Yes, you can think about it that way. That it has a lot of modules, and these modules are connected to each other. As users, we cannot have one or two machines working for us. So what happens is that for training purposes, we actually take a VM which simulates the cluster. Okay. So what happens is that there are three modes in Hadoop. What is the first standalone mode, pseudo distributed mode, and the entire cluster mode. So cluster mode is, which we have actually discussed right now, is for companies like Google, Facebook, or normal companies that you when you can have a bunch of machines or something like a data center. But for the training purposes, we can have these particular processes like in HDFS we have name node and data nodes. We can have these simulated on a single machine. So what will happen is that, sir, that I'll give you, let's say you can also go on Cloudera and see that it will be a VM which will be actually simulating the entire cluster for you. So is it clear?
No.
Space of the VM. So it's a Linux box.
Okay.
Okay. So does that answer your question?
Mm-hmm. And the regarding this one, right? Like, how much is a big data? Like a big data means what examples you're going to provide it? Like how millions of the data? Like what type of tables you're going to use it? Like
Yeah, she'll be
just to
Anushruti.
identify
Yes, yes. So
picture
in
on that.
yes, yes. In the coming slides, you'll be knowing what kind of
Mm-hmm.
the current slides. We are speaking about SQL and NoSQL. So you'll find a difference between the SQL database
Okay.
and the NoSQL. So you'll see in the current slides.
Okay.
Okay. So there is a problem at Anushruti end. So I'm trying to see. So she already rejoined. So meanwhile, so let us continue from where she has left.
She's coming.
She's coming. So meanwhile, I'll try to uh, talk about the NoSQL and the SQL part, which is the next section.
Okay.
So just now she has talked about the lot of rings example, where in which how data simulation has been used to predict and do an analysis part. So in the next slides, we'll be talking about NoSQL. What is NoSQL and what kind of database is a NoSQL? So literally speaking, NoSQL is simply not SQL. That means it's not structured. If you compare the main difference between SQL and NoSQL DBs, in the SQL DBs, what we try to do is like we define a schema and then we try to store our data in the SQL DBs. Whereas in NoSQL, the main difference is whatever raw data is there, the big data which actually gets populated from lot of applications, we just push that raw data into the HDFS, and while trying to processing on the data, we define our own schema and try to do an analysis on it. So the main difference between NoSQL and SQL is in SQL we define a schema, like while designing a database, we define the structure of the database, we define all the fields, what has to be the uh, each field sets and everything, and then we actually try to save our data. Whereas in the NoSQL DBs, we just push the raw data uh, as if we, because it's a very huge data, we say big data, so it's not structured properly, and we can have our own schema defined, and we can actually try to do an analytics part. So in the NoSQL category, we have all the kind of database like MongoDB is there, CoshDB, HBase, right? So all these are open source and it can be utilized according to a business need. The slide simply speaks NoSQL database, not only SQL, a simple approach for data management. So that's what actually we discussed earlier. And this NoSQL DBs are mainly used in the distributed data analysis. See, what is the main power of a NoSQL DB? Since data has been distributed on commodity servers and it was spread across the clusters, so the chunks of data is easily saved, and the power of NoSQL DBs is it can be spread across all the systems, and it during the retrieval process, whatever schema we define, it can be utilized, and we can go ahead and do our analytics part. So the simple characteristics of NoSQL are simply it's open source, as mentioned earlier, it's schema-less and cluster-friendly and non-relational. So the traditional DBs are relational DBs, and SQL part, that's from the SQL part, whereas the NoSQL DBs are non-relational. So when we talk about schema-less, the main difference which was mentioned earlier is only with the schema. So the main power of NoSQL DBs is with the uh, customizing your schema and defining your business need and trying to retrieve it. So the best and the big advantage that the NoSQL DBs have when combined with Hadoop is the processing power. That processing power really the speed at which the data can be retrieved is really helpful for doing the analytics part. Moving on to the next file. So if we talk about NoSQL, there are four categories in which the data model has been split into. Some SQL DBs are split according to the document format. Some others are split in the column and family format, and there are other some DBs which defined in the graph format and key value format. So depending upon this, we do see a lot of NoSQL DBs coming in the market, which fall either one of the other categories that has been mentioned over here. So in the document format, we have the MongoDB, which you might have heard about recently, and also the HBase part, which we'll try to cover in our regular sessions. and Cassandra is the most powerful DB, which is huge hit in the market. Similarly, Raik and Redis in the key value segment, and in the graph format, you have the Neo 4G. So, any questions?
These are all belongs to NoSQL, right?
Yes, Kishore. So these actually belong to the NoSQL part. And recently we do hear about Cassandra, HBase, MongoDB. I mean, frequently we do, if you go and open a wiki or hear about Big Data or Hadoop, you do see this MongoDB, Cassandra, HBase. People try, I mean, like, it's end of the day, it's your business requirement which actually demands for you to go ahead and choose the respective DB. Any more questions? I just want to pause on here for a while.
I didn't get it actually. NoSQL means how it will work. This one
Yes,
means is like Hadoop. We don't have any SQL behind the when you develop the real time, right?
No,
No
no.
SQL, right?
Yeah,
SQL we don't
let
have.
me clear your doubt. See,
Uh,
when we
uh,
speak about Hadoop, Hadoop is a
mhm.
distributed file system, right? So,
Oh, yeah.
so that the data has been split across the commodity computers, which are nothing but economical based computers, the normal kind of machines that we use at home. So, while trying to use the power of Hadoop, either you can push a data from the normal regular DBs using a tool called as Scoop, or you can actually push the data which is unstructured, I mean to say, using Flume. So either ways you can actually try to push your data into the HDFS. Got it, Kishore?
Okay. Means
So
basically saying we need to push the file,
yeah,
right?
see,
Like if you regular, right? Like if you go to the client server technology, right? Like other technology, if you right, I'm a business object developer, right?
yes,
What we do means when you develop the any reports or anything, we need the tables, right?
yes,
We're
yes,
going to find the tables, right?
yes, yes,
Find the connection, right?
yes,
Like
yes,
Hadoop, how it will work? I didn't get it. Like end of the day question, right? I'm
yes,
not clear. What is a Hadoop? Hadoop is a framework. Is correct. I
yes,
got it.
yes,
Means
yes,
it's like how the like a real time when you compare to client server, right? Take
yes.
example and show me what is the difference between the client server, how that will work compared to Hadoop, how that will work, so that I get the idea, right?
So let me give a simple example. See,
Okay.
you develop a simple desktop application.
Yes.
So
Mm-hmm.
which has a backend DB, right? Either SQL or Oracle.
Yes.
Okay.
Yes.
Either it's a desktop
Mm-hmm.
application or a
Mm-hmm.
web application. Fine.
Yeah. Anything.
Anything.
Yeah.
So
Mm-hmm.
we'll take a simple example. Now,
Mm-hmm.
you wanted to search for some item inside the application. Okay.
Mm-hmm.
So for that, what you'll try to do, you'll try to just do a search in the analytics section or the reporting part, whatever has been defined for you. You go into the window, provide all the search criteria, and try to pull your data. Right.
Yes.
So this is pretty much an easy one to understand. Suppose
Mm-hmm.
suppose I wanted to push ahead on the same example in a wider into a wider angle. Suppose I wanted to do from my business perspective, I wanted to do a search and find out how my users are doing, what kind of I mean like interest are there for the users from a Facebook point of view, or from a Twitter point of view, or from a I mean like uh, from an aeronautical point of view, or from a marine point of view. So,
Mm-hmm.
do you think there is a difference in the data for doing the search in between a normal web application and from the communication perspective or a telecommunication perspective or from a marine perspective? Is there a difference in the data between those two examples?
Huge data is there, right? When you go to all the other
Yes,
systems,
yes.
right?
So,
Yes.
so there is the data. Suppose if you take a Facebook example, so
Mm-hmm.
you have a like, you have a comment, you have a share, you have an image, right? And
Yes.
you have message, comments.
Mm-hmm.
So
Mhm.
When you try to, how Facebook is trying to save this data, because data is not structured, a like, a comment. In
Mhm.
the comment
Mhm.
also, people try to text as they like, right? You place a bracket,
Mhm.
place an image, you place a smiley. So it's like a user is trying to put his information in whatever way he likes. So how you are trying to save
Mhm.
this information? So the data that,
Mhm.
see, in a single Facebook account, millions and millions of users are increasing day by day and trying to use. So
Mhm.
if you take a normal traditional database,
Mhm.
so the data part is it's like uh, current. If you come, if it's the capacity or the intensity of for doing an analytics using a traditional DB is really a bit hard. That is the reason why Google came up with a plan for doing analytics, and that actually triggered the Hadoop HDFS. And HDFS has the
Mhm.
power; it has a power to do the processing part. It's like you push data once and do your processing a number of times.
Mhm.
Got it right? See, because
Yes.
this Facebook, Twitter, or whatever, Facebook, Twitter, or LinkedIn, or any communication system, or any marine system, or any military system. See, the data is in volumes. The volume is like petabytes, gigabytes, petabytes. So it's enormously increasing day by day, second by second, right?
Yes.
So for doing analytics, what we try to do in a normal traditional system, we take the raw data and we try to do for doing an analysis part, we archive the data and doing in and even though we archive the data, only we try to analyze 20% of the data. The rest of the 80% is being archived and left back. So that means
Mhm.
we are not doing a proper analytics
We are not doing a proper analytics
on the existing data which has been saved earlier. So for doing analytics, what we try to do in the 20% of the data, we try to run our ETL processes tools, and then we refine the data and then push the data for doing the reporting section. That is the traditional system. Here, when Hadoop came into picture, there is no question of archiving our data. We just try to push our data, raw data into the HDFS, and after pushing the data into the HDFS, we have the data for uh, and it's like lifelong. You can save it because it's raw. Whatever way the data is coming, we are not refining it. We are just pushing into it. I could hear a echo from someone. Try to unmute someone if you don't mind. Hmm? Okay. So whatever, so the raw data that is there has been pushed into the HDFS, and for doing the analytics part, it becomes so easy because while we push the data into the HDFS, we have not defined any schema. But while try to do a processing part, we define our own schema, and we can go ahead using the analytics part using either of the tools of Pig or the Hive tools, and we can do the analysis. That's how actually this Hadoop has become more famous in the decision market.
this Hadoop has become more famous.
So you got it, Kishore, or still you have paused on it? Please
Still not clear.
see. The other way is like the data. It's a, you know about 2D and 3 dimension, right? See pairwise
Yes.
data.
Mhm.
See in HDFS you can save your data in a pairwise section, key value pairwise. Like um,
Mhm.
if you had seen the in our while we are in the schooling days, we might have seen linear equations, right? Where data is saved in as a sets and subsets, key value pairs.
Mhm.
Uh, you have any idea on it? Linear equations, which we actually studied.
No, no, no. I got, but my question, right, is suppose there is a no tables behind the Hadoop, behind the scene, like it just like a data modeling, like a star schema, like a
Yeah,
what exactly
yeah.
Hadoop?
See, these DBs which are actually there, right? The SQL DBs, no
uh,
SQL DBs. So they see. Uh,
means
suppose
where is the Hadoop here? Which one? The
See, Hadoop is
HBase,
the
HBase is
Hadoop is the distributed file system in which the data is saved into the commodity servers, and these get attached or in collaboration with the NoSQL DBs. You actually do the processing. So it's again an integrated suite of all these tools. When you say big data and Hadoop, got it? Let me actually move back to the earlier slides. Give me a second. See, you see this file of mine, Hadoop ecosystem.
yeah. Mm-hmm.
See, HDFS actually sits here where the data is.
Mm-hmm.
Okay, so here you have your raw data which is being pushed using Flume and Scoop. See, the structured data from normal SQL DBs can be pushed into HDFS using Scoop, and the semi-structured or the unstructured. Semi-structured is like XML, and, and the unstructured kind of thing is like your data that comes from any aeronautical source or marine source. Facebook. Facebook is again unstructured data. Twitter data is again unstructured data, which can be pushed into the HDFS. So HDFS is a distributed file system. It's a file system, and which along with the collaboration of NoSQL DBs. See, here the data you save, and when you use a HBase or any other data model, so the data model has its own. See, let me again move into the back to the earlier. Here, so it's see, there are four kinds of data models. One is of a document model, the other is of a graph, the other one is a key value, and the fourth one is column and family. Let me move. See here, key value pair is one format which you can use to pull data from HDFS and do an analytics. And what kind of DB that you use for key value pairs? Key value pair means you have Redis and React. So Redis and React uh, are nothing but NoSQL databases which actually have the data in key value format. Got it?
Mm-hmm.
Similarly, the other file, this is a document format. The document format data model is like this. Like you have a ID and an ID associated with some value. There is another ID, a customer ID, which has an associated value. So this is like one format of which you can have your data from HDFS, and the associated DB for document model is MongoDB and CouchDB. So MongoDB falls in the document format. So,
Okay.
got it right?
Mm-hmm.
Similarly, the other two
It's like
column,
XML form.
similarly, kind of. Similarly, the other one is a columnar database, where in which column, row and column format is followed, and the kind of DBs which actually
Yeah.
suit into this model is Cassandra. So Cassandra is a column format. So how these DBs are useful for you while trying
So
to
where is the Cassandra?
Cassandra is a column and family. Here. Got it?
That is a database, right?
Yeah.
Cassandra is a database,
Yes. All these are NoSQL databases. These are called as NoSQL databases because the schema is not defined earlier and data is not pushed. See, if you take a traditional database,
no, these are all sample. These are all are related to the samples or NoSQL databases, right?
exactly,
Cassandra and
exactly,
HBase, whatever
100%,
the
100%.
graph or means
Yes,
what you means basically structure unstructured data means file store, right?
yeah,
End
100.
users, right? Like a Facebook, right? When you click on something, they will store the unfiled structure.
Yes,
Unfiled structure to the they're going to be convert to the structure format. Is it correct?
So you need to define your schema and then you push it.
Yeah, that's something.
Yes.
After defining a schema, we're
Yes.
going to convert the unstructured data to structured data.
So that according to the different kind of NoSQL DB format they fall into, we actually define the schema and try to do a processing from HDFS using these NoSQL DBs. Got it?
Means the files basically will whatever the suppose if you user right the storing front end something whatever the
Yes.
Facebook right
Yes, yes.
means we'll take that one we'll put it in one file and put it in files to push to the HDFS. Is
Yeah.
it correct?
Yes, you can. Suppose
And
if you are using
HDFS
Facebook.
also
Yes.
define the structured data tables. Okay, they
So-
can join the unstructured data to structured data.
Yeah.
Is it correct?
Yes, yes. See, at the end of the day, when you try to do a processing
Mhm.
and wanted to get a report from any kind of data, right? You need to have a structure defined and pull it and do a analytics and then present the report. Got it right?
Yeah, okay.
So
Means structured to means basically how do you going to convert the unstructured to structure?
that is the area where these databases will be helpful for us.
Oh, okay. Uh-huh.
Got it. See again, which database, which NoSQL DB you wanted to use, it depends upon your business need and the kind of expertise your organization has can fulfill. Got it right?
Mm-hmm.
I hope you got my point.
Yes. Basically, we are going to do the unstructured database to structured database, and we're going to give to the DB database, whatever the developer, and that guy is going to take that one database and put it in the regular use. Same thing. If
No,
you need
it's
a report,
no, no.
whatever maybe you can.
See here, we won't. There is no need for sharing it to other because the kind of roles that you do is like you push the data into the HDFS and you try to pull the data into the NoSQL DBs, and there you do analytics. Analytics in the sense like you try to see like uh, suppose if you go and log into Facebook account, you try to share some pages or you like some comments or you like some pages. So all these are nothing but your actions, right?
Yes.
So these actions are actually analyzed by someone. Who's that someone? It's nothing but Facebook. So Facebook has an analytics team who are data experts who know about the HDFS, Hadoop, NoSQL DBs, Big Hive. So they take the data from HDFS. The data from HDFS is nothing but the raw data of all the users which has been pushed into the Facebook. Okay, this data has been pushed into HDFS and someone has done some analysis using these tools and end of the day they gave a report like Kishore is interested in taking Hadoop course within 1 month. See, this is the end result which Facebook wants, right? You got my point? So how this end result can be achieved? It has been achieved doing some analysis of from huge data, right? You got my point? So that is what is the advantage Hadoop gives. And not only Facebook, if you try to see, I'll give a small example of recently elections. Some party was able to win in their elections only because of their analytics. They had done the strong analytics and they found in which area we are strong, in which area we are not strong. They found out in a particular area they are not strong. And they tried to have a very good campaign done and they were successful. Same was followed by Obama using the analytics of big data and Hadoop. Got it, Kishore? So that is the overall scenario. Got it? Any more questions?
Okay.
I give a simple example. You go and like something, and tomorrow you see the something of your interest being popped up somewhere on top of the window or at the bottom. How it's coming up? Only because of this analytics that has been done.
Mm-hmm.
Got it right?
Mm-hmm.
So hopefully in the regular course, when we go ahead, when you know more, you can actually understand how actually the analytics has been done, how the NoSQL DB is helpful, and how we use the kind of data models to present. So that's a detailed part which can be taken up down the line. Fine. Here we are trying to give a glimpse of the power of big data. Just wanted to give you an understanding how big is the data and how Hadoop is helpful in using big data to do analytics and have the end result achieved. Got it? Can I move forward?
Mm-hmm.
Can I move forward?
Yeah.
So these are the different,
Yes, yes.
yeah, these are the kind of different data models, and as discussed earlier. So this is a key value format where in which the data has been mapped in the key and value formats. And the other file is a document format in which it is like a simple document. We have data in rows and lines, line by line. So you can actually have your data in this format and then do analytics on it. The other one is a column, row and column format where you see the columns, the column key. Again, it's again a key value. Key it has a columns will be defined and a value is there corresponding to that column. And whole of the first set is called as a column family. So this is it's again a particular kind of a format in which you can actually present your data and do analytics. So the data has actually been uh, in the explanation part. So initially the data is actually split and individual on each and every split you do run your jobs and the result actually gets uh, mm, mm, added up and you have your end result for analyzing your end result how you wanted to present yourself. The same example that I gave for Facebook, how a particular user is able to go ahead and feel like he's interested in this. That's the end of the way Facebook or Twitter or LinkedIn is trying to uh, uh, come out by doing the analytics. So the data is being split and it's been shared across the HDFS to show how the analytics power can be achieved. So this is a simple example of how you can actually present your data in this format. See, the earlier what are the document format, the key value format, and the column and database format. All these three
Mm-hmm.
they actually fall under order line item and product they fall under this type of category. So it's like you have a line item and then you take it in order format and it comes up to a line format and then you push it to the product format. So those three fall under such type of category. The fourth one is a graph. This is like a huge cluster kind of thing. Again, it's a no SQL one, but you define your data in such a format like it's a graph way format. It's totally different from the other three that we have talked about. So again, in depth if you go, because it's totally, if you say a simple graph by the diagram, we can easily see a lot of things are mapped between each other. So the way from where the arrow comes up and from where the arrow actually moves ahead. At the end of the day, it's again the business need which actually demands which kind of DB which you want with your Hadoop. So the graph format data is like totally clustered one and it's a bit complex one. So which kind of DB NoSQL database which you wanted to choose, it's again a choice from a business whether your data, your business requirement is high priority with respect to consistency or availability. If it's with respect to consistency, if you take for example the financial domain, so the consistency of the data is really really important. Or whether if you take for example Amazon, in Amazon the need of product in the store is really important. So there the availability factor comes into picture. So when you actually try to do go for a choice of the NoSQL DB, it's a business demand on whether your business demands consistency or availability. It's again a business need. Based upon that, you try to go and actually try to choose your NoSQL DB and try to club up with Hadoop and do your processing and the analytics on top of it. So there we end up the basics of Hadoop. So in my next fall, I'll try to speak about the future of big data. So there is a huge demand for big data down the line because we cannot expect the range at which the data can move ahead day by day, interest by interest, person to person, lot of usage can be seen, and the power of data, big data is huge, and we do see lot of other open source technologies which will try to catch up and try to use the most advantage way in which the analytics can be done to achieve. So the future of big data is heavy, and everywhere we do see like opportunities wise or from a business perspective, the future of big data is really uh, big, believe me. So Kaggle is one, I mean, like uh, a community which actually tries to do data analytics, and it's really a good place where people try to, whoever interested in doing analytics, Kaggle tries to give some questions, problems which if we are able to go and solve it, you are really an expert driven guy, and if you're it's open, and a lot of people try to, it's like a uh, post where people try to go and try to solve problems, and if you are really kind enough to go ahead and do analytics part too, and if you are a recognized person from Kaggle, you are your visibility is like anything. So it's a very platform where data challenges
What
are
is it?
started. Kaggle is something like a portal,
What?
like a question and answer kind of portal. People try, lot of companies try to get solutions from Kaggle. Suppose like Facebook is there, Facebook wants some analytics to be done. So it gives some sort of solution problems for it. A problem statement can be anything like, suppose you have your own company running and you have a huge data,
Mm.
Kishore, and tomorrow you go to a MIS guy and says, boss, see, I wanted a report by month end, which clearly gives me a statement, uh, how many number of people really approached our company, and in that how many were able to close the deals within so and so range. If it's your requirement, and it's a problem statement, and such kind of statements like these problems, companies try to, if they're able to solve it from there, and that's good. Otherwise, Kaggle really provides consultancy solutions for them, and they help in solving the problems of huge problems, major problems, not any kind of problem. And as a simple user, you can log into register in Kaggle and try to solve any of the problems. If you're able to solve them, you will be recognized, and your profile really elevates like anything. So you can go and do a search Google of Kaggle. Sure, fine.
Mhm.
Hmm. So
Yes.
so today top companies take Kaggle's help to solve data challenges because analytics has that much of power. And from a job opportunities perspective, I mean, like rather than me speaking, you might have seen everywhere the mails coming from people, how the opportunities are actually being projected and seen. So data scientist positions are there. I mean, like it would be there, and people uh, can't escape out of doing analytics. So everyone are trying to switch their roles from normal dev role to analytics role, from a test role to analytics role, from a normal admin support role to Hadoop supported admin role. So huge opportunities as far as the jobs are concerned. So no doubt about it. So the trend you can see, then from a package perspective also, huge paybacks are being given for people uh, who are really have the skill set of this Hadoop. And, and other aspect is like, see, in Hadoop, it's like you have MapReduce, you have pig, you have hive, and you have mouth. So specific companies actually need people who are able to do some programming analytics part using MapReduce. And in Facebook, like companies have a requirement of people who are good in doing taking the use can use a tool Hive or Pig. So like this, it's not like everyone knows everything from a manager perspective, from a project manager perspective. If you know everything, that would be good because at the end of the day, while you're trying to design your deliverable, so you need to have all the pieces knowledge. But if in 1 year, if you become an expert, too good. Like either MapReduce, for MapReduce, you just need simple Java, basic knowledge of Java is sufficient, not advanced. Sufficient is basic Java. That's fine because map you need to write your functionality on map and reduce. That's it. And as far as pig and hive are concerned, they are like command line statements, or pig is something like a SQL syntax kind of create kind of commands are there. So it's not that much hard. It's just hands-on that you need to do. So opportunities are there in every segment. It's not like only on a specific or every in every bucket you can actually pick up and see. If you are an expert in hive, people want you. For an expert in pig, people want you. For an expert in MapReduce, people want you. If you have an overall view of Hadoop, people want you because they wanted you to design projects. And the other big part which we will definitely see is like they'll the people who are doing testing, they also need to, there will be huge opportunities for Hadoop testing, big data testing. How do you test huge data? So for that we need to know about all these things. So opportunities wise, it's heavy. So there ends our session, and I just wanted to speak about our.
How many sessions the course?
Let me open up for you.
Hello?
We are plan to cover up in 10 sessions, plus or minus one or two, depending upon our bandwidth. So every session will take around 1.5 hours. It's a 3 hour session. Like
3 hours
hello.
means 1.5 hour or 3 hours?
No, it's sorry. The total 1.5 hour. In between, we'll have a break, and we'll try to cover all the sessions, all the topics that we have mentioned in our portal. So you can have a glance at that VenEma weebly.com, where we have defined our course structure. So just have a glance at it, and apart from that, we'll also help you prior to taking Hadoop sessions. We help you.
No, are you working on Hadoop? Who is going to working on Hadoop?
Yeah, our expert Anushruti, who actually presented, she is an expert in data analytics. So she'll be taking the session. So she's already a data scientist. So a lot of rich experience, real-time
Which
experience.
company she is working?
She's working for a company called as MBT. They are core data. It's not Tech Mahindra. Hello.
Okay.
So
Yes.
yeah. So that's a she's having she has a rich experience from there, and myself also about to switch into Hadoop testing. So I'll also be there to help you out. In
What is your name?
So my name is Venkat.
Venkat. Oh, okay.
So you know me, right? So yeah.
And you,
Yeah, so VenEma is a team. We are a group of working professionals who are spread across India. We came up together with a collaborative approach to provide online trainings, especially on niche skills. So if you have go and have a glance at our portal, you'll definitely see this trainings that we have mentioned were all related to niche skills. So uh, anyone is welcome to join with us, learn from us, and later they can also join us to spread the knowledge across the globe. That is our main intention. Hello?
Can you send me content review?
Pardon, Kishore?
Okay, can you send me course content
Yes,
by email?
Kishore, you can actually go through
Can you send me
our.
course content?
Yes, Kishore, you can actually go through this portal of us. Let me open it for you. You see our portal, right? Hello, Kishore?
Not really.
So this is the one. Are you able to see my screen? So you see our,
Yes, yes,
say, I mark this one, right? So this is the one actually you can have a glance.
yes.
You can actually open up and see. Let me open it for you.